Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Welcome into another episode of DevOps Accent, a podcast where we, the co-founders of MKDev, get together to discuss all things around DevOps, cloud-native technologies, artificial intelligence, data, and just in general things that got our attention this week, past week, future week, whatever. Thank you for coming. Thank you for listening us. Don't forget to subscribe. Don't forget to give us like. This helps us a lot because this is not the first time you are listening to us. Apparently you are interested and for some reason you are not subscribed yet. Fix this problem right now. And hi guys. Hi Pablo. Hi Kirill. Long time no see, Kirill, especially you on the DevOps Accent. How have you been?
I've been great. Thank you, Leo. It's been a while since my last podcast. 2 months, actually, I think. What kind of vacations?
Where was Kirill, please? Where was Kirill?
Kirill was traveling around the world, and he's keep traveling.
It's illegal to record podcasts when you travel in USA. That's a known fact.
Really? Anyway, I have kind of celebration for you too, because we are kind of celebrating 10 years of Kubernetes. Technically, it was the last previous month. 10 years of Kubernetes, they appeared in June. By June 2014, and they were launched by Google. And the things that Kubernetes often dubbed as K8S, I don't understand what this means. How Kubernetes and then 8S, how it translates?
It's the number of letters between K and S.
Really? 1, 2, 3, 4, 5,
yes,
6, 7, 8. Yeah, you're right.
That's a common way to abbreviate. There's also, for example, A16Z, which is for Anderson Horowitz VC fund. That's why it's abbreviated to A16.
For a very long time, I thought that 8 is somehow translates to mimics the word Kubernetes, skater boy from Avril Lavigne, and there was an 8 letter, and I thought it translates into this, but then I decided to put it correctly, and I figured that 8 does not translate to Kubernetes at all, and why it's even 8?
It's Kate,
yeah. Anyway, so this tool revolutionized the way we manage containerized applications, or at least you guys. It's a brainchild of engineers who previously worked on Google's Borg system. I didn't know that. I was just Googling about the history of Kubernetes, how it appeared, what is that. And for those, if some of you didn't know, Google Borgs is essentially the predecessor of Kubernetes. It's like the original container orchestration tool that helped Google efficiently run their multiple services at scale. And the thing is, Borg is still very much alive, and it's being used at Google. And Kubernetes has taken the best ideas from Borg and made them available to the broader tech community as open source in 2014.
Need to have a Borg instances, and then inside Borg is when you have Kubernetes. So at this level, still Borg is there, because Borg is everything in Google Cloud these days. It's the way that they are working, and the old way, and they continue working in this way.
This is interesting because, I thought Kubernetes. I know that Kubernetes is kind of cloud agnostic, and it should be run on any kind of cloud. And it is funny that if you run it on Google,
Kubernetes in Google Cloud is what I was telling. If you use ZK,
yeah, it is funny that you still have to install it on top of the existing something inside of the Google. And in its early days, like because it's open source, because it's open source nature, and the growing popularity of containers, Kubernetes gained its traction. And I wonder how you guys, like how you encountered this Kubernetes first. What was your original impression? Like, was it like, oh yeah, finally someone released a useful tool, or like, oh meh, what is that?
I think that this doesn't appear like that, because we're talking about 2014. Most of the people and most of the companies that were using monolithic, maximum they were using, the companies was using something like a VMware, because they were doing this different kind of virtualization. Private cloud, something like that. Some companies were using AWS, but it wasn't something that it was, the mind of everyone. Like Docker was there, and many other things, but it's a technology that appear, and then we start to change, because there is a movement in the architecture from this monolithic environment to different microservices environment. Is when we start to hear about this content in the microservices, and we need to have an architecture where to have all these components, and this idea with the containers, and the idea of I have an application, I have a component that every time that I start is going to do the same. This concept of repetition, and you need to think that in 2014 there were, for example, few positions for DevOps. So it's a global change in the mindset of the IT people. So it's not only Kubernetes appear new architectures, appear new job position, appears new way to work with, for example, tools like Jira and this dynamic way to work. So it's not only Kubernetes, it's a big number of tools like monitoring and many other tools that appear during these years. It's a big period of time.
So it was like a huge leap on the industry, that from different angles, different companies, different tools appears at the same time, more or less.
Yeah, it's funny because, for example, Scrum also became like went from something that exists to something that is like a religion, and everyone started introducing Scrum, converting all the process to Scrum, hiring Scrum consultants. And I witnessed like from inside a couple of companies that suddenly you have to redo everything to be Scrum. I think what triggered Kubernetes originally is because Docker was released in 2014, I think, as well, or 2013. And then once Docker appeared and everyone realized containers such powerful abstraction for developers, and then Google took, I'd say like the best parts of Borg and built Kubernetes as a new system on top of Docker. But it took a while till Kubernetes became something even close to Borg, because, for example, it could not really scale that well beyond a certain number of nodes. So this in 2014, Borg already was powering all of Google data centers. You can imagine just the scale. And Kubernetes was nowhere near being capable of handling this level of infrastructure. Even still today, if you try to have Kubernetes manage completely one of the Google's data centers, I don't think it's going to be possible. And they still do it with Borg. And as Pablo said, like if everything in Google Cloud as well is powered by Borg, every virtual machine even in Google Cloud is a container inside Borg. It's pretty impressive.
And do you recall adopting Kubernetes? Was it like easy part? Because from what I remember, there was a steep learning curve at the beginning when Kubernetes was released, and also there were a number of challenges around security and general complexity of Kubernetes for the wider audience. Or it was easily adopted?
I think honestly that it's way harder now than it was back then, simply because Kubernetes was a much more primitive system. It didn't have so many components inside. Even one of the most common things that people use today in Kubernetes is a resource type called deployment. And when Kubernetes appeared, there was no deployment. You had only replication controllers. So if you want to deploy a new version of your application, you had to figure out a way to switch traffic between two replication controllers. and some deployments appeared 2 or 3 years later, and they were kind of copy and pasted initially from OpenShift. And what's funny is that OpenShift also appeared more or less like 3, 5, 6 months after Kubernetes. So there was lots of new stuff. Terraform also appeared in 2014 or 2013. It was like a revolutionary year. So all these things that now define day-to-day work of infrastructure engineers appeared 2013, 2014.
Very productive year. I remember you've been creating a number of courses, lectures on Kubernetes, explaining to people how to use them. Do you think like they're still relevant, or like it's changed so much throughout the years that you have to relearn everything from scratch?
I think all the content on the first few years of Kubernetes is now obsolete just because they refactored. For example, Docker. Initially, Kubernetes had Docker hard-coded in it. But thanks to Kubernetes, there was the whole discussion about having open container standards appeared because Google depended on Docker to do any changes inside Kubernetes because in the end, it's kind of powered by, it was, at the root, there was Docker. And then Red Hat and other companies wanted to contribute, and then Docker company was like, no, we don't want these changes. So thanks to this, Kubernetes changed the way it works, and now it has this container runtime interface that you can basically plug in any container manager, and everything follows open standards. We have the whole course and articles on our website and YouTube channel about this, how it works. Now it's better. Like the content from 2-3 years ago about Kubernetes, I feel it's more or less the same because Kubernetes entered the stage where I think even in the last maybe 4 years is that it's very stable and the core feature set is there. And even the core features that are enough for most companies, they did not change much in last years. There are more advanced features that would help with, for example, platform engineering, but the Kubernetes is at this level that it's already like a stable, it's 10 years old technology. So there are no big explosions in the space anymore.
We need to think something too, because when Kubernetes appeared in 2014, because we need to remember more or less the time, 2013 Docker, 2014 Kubernetes, 2011, the first time that a person talked about microservices, 2011, when Jenkins appeared. In this period of time, nobody was working in infra. So there were infra, but there were not this concept of infra. We need to understand that everything was related to the software. So we have a piece of software that we want to execute in some place. So, and the concept of what we have today is completely different because we have teams only dedicated to infra and teams that are only deploying infra and exploiting the infra. And we need to think that before 2011, more or less, something like that, most of the people was working not on cloud, was working on-prem. So, and then when Kubernetes appeared, as Kirill was telling, it's not something that explode. It's something that it's a tool that could be used, but to be used in the way that it's used today, cloud needs to explode. Microservices need to explode. The pipelines, like for example, what Jenkins was doing, needs to be used for all the application. The people needs to jump from this monolithic to different components, not an only component. And after many years that the people start to think how to change the architecture, and after many people working on that is when Kubernetes is able to do something, and Kubernetes is what it is today. But again, today, there are many places and many cases where Kubernetes is not needed, and many people is still using Kubernetes because people think that it's cool. Because these days we have things like, for example, Cloud Running, Google Cloud, Cloud Function, many little places where you can execute only one container or two. That in many cases, we can say even in most of the cases, is everything that you need. So, and there are people who is using Kubernetes only because it's Kubernetes. So at the end, still, this is something that we need to think. But it's cool that this kind of components of tools, or these applications are still there, and are improving day by day. And what is interesting to see where is going to be Kubernetes in the next 10 years, in 2034, because you don't know, maybe there is something new, the architecture change, and now Kubernetes is not needed anymore. Or no, it's something that is, because I cannot imagine Kubernetes with 20 years of history in this world where nothing is with 20 years. Everything is after 5-6 years disappear. But okay, could be interesting to see what was happening with Kubernetes.
What's funny is I think I'm always irritated that Kubernetes is like a default choice for someone running things in the cloud, because that's also not the benefit of having Kubernetes, because originally Kubernetes is the system that allows you to run workloads on many, many machines, but it was built for a physical world, or let's say for the VMware world. Because what Kubernetes gives you is all the an easy way to run many, many copies of your applications distributed around a big cluster of machines. So it kind of makes the capacity management of your existing infrastructure easier, which goes a bit against what cloud providers try to offer you, like AWS, for example, where they try to make more and more services where you don't have servers in the first place. So to me, every time I see Kubernetes in the cloud, especially like in AWS and Google Cloud, I'm thinking like it makes no sense, because cloud providers give you serverless options where you don't need to think about servers, but you somehow want to have still EC2 instances or GKE instances and put on top another layer. So now you have 2 layers of managing like virtual machines, and then on top you have a layer to manage containers. Each in the cloud environment, it's totally unnecessary for most companies, if not all companies. And it's funny because in this time when Kubernetes appeared, 2014, and Docker was like the most popular thing, AWS already released AWS Lambda, but okay, it took Lambda quite some time as well to become super mature like it is now. And they also released ECS, Elastic Container Service, which is much, much simpler and fits for most companies that want to use AWS. And it's funny and sad to see how ECS kind of lost this battle in the people's mind, because it's something AWS specific and people just want to use Kubernetes because you don't have a vendor lock-in. Even though ECS, if you're using AWS, it's in most cases much better choice to run your containerized workloads. Like on Google Cloud, you can use GKE, Google Kubernetes engine, but for most applications, something like Cloud Run is much simpler and easier to use.
But okay, in whatever case, Kubernetes is going to be there for at least for 10 years. And it's true that day by day is more and more complex. And this is something that for me could be one of the main problems for Kubernetes, because it is a tool that they are adding so huge amount of complexity. For example, Kirill, you have a conferences, you have a talk. Where it was that? In Portugal? I don't remember. But okay, Kirill was explaining, the amount of resources when you define a container, what is the amount of resources that you need to claim to your container, depends of the machines, depends of the different limits, and it just start to add more and more complexity, and it's crazy, because at the end, you don't know how much resources you can offer to your container that you are, let's say, taking out from the worker, and then the worker is not using these components. It's something that day by day, because there is no one parameter today. There are 2 or 3 or 4, and you are adding more and more and more. And at the end, this complexity is making that the people is telling, okay, maybe I prefer to go to EKS. I prefer to go to Cloud Run. I prefer to go to something that is simple for me, because in most of the cases, most of the scenarios, you need something simple, not something complex.
And this is what I mean by Kubernetes having this, basically forcing you to think about all these requests like CPU and memory, like you're still working with virtual machines, VMware and stuff like this. And I think this part of Kubernetes in the cloud environment became less and less relevant over time. Okay, now we have this, let's say, trend of moving back from the cloud to on-premise to cut costs. And then Kubernetes is really a great tool to be there on-premise because it handles so many things and it's an open source and standard, most popular tool. But in the cloud, what I think is a good place for Kubernetes today is what Azure and Google Cloud are doing, is that you don't really use Kubernetes directly, but you use the abstractions that Kubernetes gives you. Because I think if you go to Cloud Run is basically initially it's Knative. So you can manage Cloud Run application with a YAML file, which is a Kubernetes resource definition. Same goes for Microsoft Azure container apps. You use container apps, you never think about any virtual machines or servers, but you work with the Kubernetes custom resource definition that defines your application. Like which container image to use, which port to explore and expose, etc. And for me, that's in last, again, 3-4 years is the most powerful trait of Kubernetes, that it allows you to build this kind of powerful abstractions. And the resource management part, I think in modern environment becomes less and less important unless you really have to manage your own data center. But in the cloud, you don't really want to manage these two layers. As I explained in the articles and in this talk that Pablo mentioned, that you have virtual machines layers with all the CPU and memory and capacity management. We have Kubernetes layer with all the pod CPU and memory management. It just makes no sense if you're going for cloud native and serverless setup.
This is kind of funny because now that you discuss, I have an impression that Kubernetes is not as vital, and it didn't create this, pivotal trend in cloud technologies. Because if we look back at what we used before Kubernetes and what we're using now, nothing much changed, right? From the user perspective, like that, you could make your purchase on Amazon. You can play video games, online video games, the same way as you play today. You could, you used all the products, the same chats, online storage, cloud storages. You were watching Netflix, other streaming services. Like, what was the part that Kubernetes played in all this that helped us improve? Like, did it even help us improve?
These kind of things you don't see from the outside, right? It's for business. It does not matter if you use Kubernetes or not. It's about how many people you need to manage a complex infrastructure, how easy it is for developers to deploy and ship new features, because Kubernetes allows you to basically create this internal system where developers can ship applications really fast. They can really self-heal applications really fast and expose them. They allowed many powerful platform engineering use cases, because in the end, what is really simple to do with Kubernetes is to have a separate platform engineering team that kind of builds this internal platform on top of Kubernetes, because it has all these open source tools and the standards, and expose this platform to developers so they can create new applications and quickly iterate on existing applications. And that's one of the really cool things about Kubernetes, that anyone can do it now, regardless of, you can do it on any cloud provider, you can do it on-premise, and it's all kind of standard and everyone has the same feature set. And you can also migrate between cloud providers, presumably easier with Kubernetes.
Again, what we are getting with this is not only a change in the culture of the application. We had Kirill, a change of the work of the people, because 10, 15 years ago there were people working in network, and this guy was working with the switches that it was there. There were guys working with the Linux operating system, or Unix, like SPUX, AIX, but there were not people related to anything related. There is no relation with containers. So it was Unix guys, storage guys, database guys. So, and these days, when you look for a job, for a new position, there are people like, DevOps guys, infra guys. I need to have an OpenShift guy. So, it's people who is working with the tools that are generating virtual infra. So it's not people that is working with the real infra. So there were a change in the paradigm, and the workers, the people who was physically in front of the machine, now is not anymore in front of the machine. Now these guys are, checking the devices and checking the virtualization, checking the containers, checking the cloud, but they are not touching what is happening. And there were only 3 groups, and now you can go to companies with, I don't know, maybe 15 type of groups of people working there. It was a moment in the last 15 years, more or less, where everything changed. And now what we have in a company, and the people who is working in a company, is completely different to what it was before. And for me, I think that Kubernetes is one of the keys, but there are many other tools that are keys for that, and many other movements, and companies like Amazon, companies like Google, like AWS, like Microsoft, that they made possible this migration from what we had and what we have today.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.
Yeah, which I think is misleading, because what people attribute to Kubernetes quite often is a benefit of using a cloud provider, like what you're telling about network and storage. Of course, if you're using AWS, so many things are taken care of the cloud provider, even if you use Kubernetes. If you use Kubernetes in your own data center, this job never disappears. You just have 2 times networking, because you have maybe network on a VMware level, then you have CNI Kubernetes. Same with storage. So then when people are saying like, oh, like we just use Kubernetes and we have like one DevOps guy, no, it's a horrible idea, because if you have one DevOps guy and you want to use Kubernetes on the cloud, it makes no sense. But what Kubernetes really removed, even in the on-prem environments, is the whole operating system management. Because remember, 10 years ago, pre-Kubernetes times, one of the main tools that as an infrastructure engineer that you had to know is one of the configuration management systems. So you had to know Chef, or you had to know Puppet, or you had to know Ansible, because it was really important how you configure what happens inside one particular server. So you had to know really well Linux file system. You had to know how to configure something like systemd units, how to configure audit, log collection, all this stuff, all inside one particular machine. And Kubernetes and OpenShift, they just remove this moment from you. Every single server inside Kubernetes cluster is exactly the same. And even now, with BottleRocket and CoreOS, every single server does not run anything except containers. So you boot a server, it starts a containerized operating system, and from this moment on, there are only containers. So there is nothing to manage. And that's, in terms of system management, if it's on-prem, if it's bare metal, if it's VMware, if it's AWS cloud, it's one of the beautiful things, because you don't need to mess with configuration management anymore in most cases. If a server is broken, you just recreate it from scratch. You just delete EC2 instance, or you delete your VMware machine, or you just reset your bare metal server. It doesn't matter anymore. It's a bit problematic, because of this, lots of people think that they don't need to know all of this stuff, that now you don't need to know how Linux works. It's completely irrelevant. But no, in the end, it's still there, and you still need to understand how it works. But from being day-to-day activity, it became something that you should know. It's like networking. You don't need to be a network expert anymore when you use a cloud provider, but you will have real issues if you don't understand how networking works.
And also, getting back to how Kubernetes influenced the current landscape, there are a number of tools that were emerged from Kubernetes, like Helm, the package manager. Also, what else? Like Argo CD also came from Kubernetes Prometheus. And I also learned that Istio is emerged from Kubernetes as well, the tool for managing microservices and service meshes. What else? What are other examples of tools that also we use most? Because the usage of Argo CD is huge today, right? And it's even more.
Yeah, because the whole ideology of GitOps and Kubernetes also is relatively new, even though there's nothing new about GitOps, but there is lots of new about how people use this term as something new and specific to tools like Argo CD and Flux CD. We have also a whole article about this on mkdev.me about GitOps and whether it makes sense. But yeah, the amount of tooling around Kubernetes stuff, there is this whole cloud native foundation, right? I think the first project in CNCF was Prometheus, if I'm not wrong. And then Kubernetes joined, and now they have hundreds of different services, and most of them are meant to be run on Kubernetes. So ecosystem is a bit crazy and confusing now. Only in service mesh, besides Istio, there is Linkerd, there is Conk, there is the console mesh, and many, many other things.
They all run on Kubernetes.
Some of them are built specifically for Kubernetes. Some of them are built to run in the hybrid mode. I actually prefer tools that are capable of running in hybrid mode, because if your deployment tool is only capable of deploying to Kubernetes, and then suddenly you have something that doesn't fit on Kubernetes, and it's also not okay, right? And for me, that's one of the issues recently with Kubernetes, is that it became a bit too much to figure out. Like the entry into Kubernetes itself, just in like pure Kubernetes experience, is now pretty low because control plane management is taken care for you by the cloud provider. But if you look at all the CNCF projects around it, it's just becoming super confusing. And you read an article like, oh, how to build a simple web application in Kubernetes. Yeah, you install a Kubernetes cluster, you install Istio, Argo CD, connect Argo CD to GitHub. Actually, okay, maybe you should just run like AppRunner or Cloud Run.
All right, Pablo, you already mentioned a little bit that you are like interested in how this will look like in another 10 years. Like, do you have like some predictions or some wishes how it should evolve, like for your personal gain, for your personal comfort, how it should be changed?
Really, no. But if we check, the speed of the changes in the last years, that this curve of speed is every day by day is faster and faster. In the last 10 years, everything jumped, because it's something that when you're outside of that, you don't discover that from a monolithic environment, without DevOps people, without anyone there, to what we have currently, everything in the cloud. There are few and few, day by day, less and less monolithic application. Everything is in the cloud. There are many containers. If you check that, I cannot imagine how can be that in the next 10 years. But again, the difference between what we had before, it was that everything was created and moved because of the applications. The development had an issue because the changes in the development was really slow. And the new version of the application, it was every 3 months, or in many cases every year. And the developers, they need to have a way to update that changes. They need to have a way to jump from one really deployment every 3 months to something, quick and speed and fast. Sorry, not like, the people was telling that every time that you make a change, you push and automatically everything is going to be changed in production in 5 seconds. This is not happening in most of the companies, in 99% of the companies. But all these components were changed because of the software. And the problem these days is that I cannot imagine that the next generation of changes are going to happen because of the software. I think that they're going to happen because of the infra. So it's the same infra, the one who is going to generate a new massive change. So it's not going to be the previous case, because the problems, you need to find what is the problem, what is the pain, and the solutions are because of pains. So, and these days, when the people is coding, there is not so big pains as it was before, and then there is no need to have this solution for these pains. But there are many pains these days in the infra. So I have to imagine that the changes will come because of the infra and not because of the software that it was 10 years ago.
Okay, interesting. Let's see how it will be in the reality.
You want to talk about AI?
Let's talk about AI. It's been 30 minutes without AI. Let's go.
Let's go.
I have withdrawal syndrome. 30 minutes without talking about AI.
Yeah. This one is not so bright because recently I read an article on fortunes.com or something like that. Says AI is effectively useless and it's created a fake it till you make it bubble that could end in disaster. So this article, it talks about the hype surrounding AI and how it's creating a market bubble similar to the .com era. And this guy's James Ferguson, who is like pretty famous, analyst and funding partners of big brain guys. So he shared some insights, views on this, and before he made some predictions, and he created analysis on post-COVID era. He predicted how the inflation will emerge post-COVID due to money supply growth, and I think so. This guy should be trusted. So he, in a podcast with Bloomberg, he pointed out like a few critical issues with artificial intelligence today. Like, firstly, he concerned about hallucinations in AI, where language models sometimes make up facts and source. And according to him, it makes AI effectively useless if it can't be trusted. And he said this phrase, fake it till you make it, to describe the current state of AI. This means presenting something as fully developed and functional, even if it's still in the experimental stages, hoping it will eventually meet expectations. While this approach might work in the fast-paced tech world of Silicon Valley, he says it's not a sustainable strategy for AI. Essentially, if AI continues to be untrustworthy and error-prone, it won't be viable in the long run.
If we talk about AI is in the market since many years. And all of us, we are using Google, for example, because AI is there. And all of us, we drive a car. And in the car, there are many things. Like, for example, when you're driving the car is telling now, if there is a plate that is telling to you the maximum speed, it's reading that for you. And many of the things that happen to us daily is AI. For sure that there is a hype in the generative AI. For sure that the hallucination of the AI is there. But okay, yesterday I was in a meeting with Paul Larsen, and he was telling something really true. The human made mistakes too. And we are not going to kill all the humans because of that. So the machines made mistakes, for sure that made mistakes, but there are agents to fix these mistakes. Introducing the first idea of this generative model to again reproduce this idea with an agent and test if this initial idea is valid or is not valid. Because imagine that you have an idea with a code, you can get this code with an agent, you can apply this code and check, okay, really what I was telling about this code is okay, because the result is what I wanted to have. So for sure that there is a hype, for sure that there are many companies spending billions and many investors spending billions in things that are not going to work. For sure, and everyone wants to use AI. But there are many cases. For example, the other day I was with Jennifer, one of the person who is working with us in Academy. We were in a place. It was in a fair, and one company is doing this Vision AI, and the idea is that they have a customer with drones that they are flying in on top of the grapes of the wine, because they have wine, and they check with 1 second if there is any kind of illness in this, in these grapes. And they can go automatically, because they do that daily, they can go automatically and detect that and stop this problem. For sure, the AI is working these days, and it was working 10 years ago too, for many things. But for sure too that there is a hype, and everyone wants to introduce AI everywhere. But we know that. So it's not something new. Everyone knows that everyone wants to use AI.
Yeah, you're right. Like, because from my impression, after reading this article and listening to him, I had an impression he was talking about more generative AI and large language models, while there are a lot of tools who are creating anything like rather useful or rather based on traditional machine learning that we attribute to AI, but in fact, it's not artificial intelligence. And the other thing that he mentioned is a bubble. Like, speaking of NVIDIA, the guy compared the current AI hype to the .com bubble, where tech stocks like Cisco and Intel soared, but then disappointed investors. And he fears something similar might happen to NVIDIA. It might face a similar fate because its current valuation is extremely high because of everybody uses NVIDIA technology. And despite all this, Ferguson admits it's tough to predict exactly when a bubble will burst, if at all. And he suggests that if the AI bubble does pop, there is still value in the market, and I think like for the product still. In a nutshell, like Ferguson is sounding the alarm on the AI hype, urging investors to be cautious and look for value in more traditional, steady-growing companies. But I don't know. What do you think?
I think in terms of AI, it's hard also to define what is AI. I heard in one podcast an example is that if you give to a person from 1999 a smartphone with the maps like Apple Maps or Google Maps, which shows the directions from A to B, that should be considered AI by the end of 90s standard, because there's a machine that basically tells you where to go properly with all the where to turn, etc. So it's also about how we define AI. But for sure, the guy in this article is talking about Gen AI, and there is a real problem that it's currently unclear how to monetize this. And this problem exists primarily for the big tech companies. So, for example, there are many examples, like one guy creates some stupid dating chatbot in App Store, and this stupid chatbot makes $200,000 per month. There are many examples like this today. So this kind of people, they win from AI, but we do not consider them to be a real business, right? Because they're not operating at the same volume as Apple or Meta or Google. So the problem is these big tech providers from them, like the global economy depends, right? If Microsoft is doing bad, then it's bad for the whole tech industry and probably for the whole economy of US. And if it's bad for the economy of US, it's also bad for all the other economies. So all these big tech companies, they currently invest. Even they like look at Amazon, they just stopped doing like any other thing lately. Not as much as Google or Microsoft, but same. So they lose lots of money trying to kind of like fake it till you make it, to make the AI like the next big thing. But right now, no one makes money on this from the big providers because it's super expensive and it's unclear how to monetize. And that's a real problem. And the problem is that they kind of try to tell you that you can solve any single issue with a tool like GPT-4, which is not the case, right? We already know that. I talked about in one of the videos that for legal stuff, for example, if you want to use GPT-4 or any other legal LLMs, as your lawyer, they're correct in 40 to 50% of cases. Otherwise, you cannot trust them. But the problem is that if you cannot trust them in less than 100% of cases, this is useless. So they can correct, but you never know if it's true or not in the end. So you can have an agent running for like 3 months, infinitely correcting itself. But at the end of the day, the model does not know. So it means you never can trust the output of this model unless you go and verify yourself. Which means that for any use case outside of something having to do with the language, it is partially like it's a good assistant, but it cannot really unlock the next like revolution in how things are working. So same for any doctor stuff. Yes, you can use LLMs to do some like analysis or diagnosis, but you need the real doctors to double verify it. For anything with language, it's incredible. That's why we see a huge downslope on all the jobs for copywriters, text editors, etc. Because in terms of a language feature of large language models, it's insane how good it is. All the translation stuff, all the text editing, grammar, language tutoring, so many use cases suggest it can be replaced by some applications with the LLM. But outside of language, all these examples like, you can give a huge PDF to GPT-4 and it gives you super cool analysis. Yes, but most likely it's wrong, and then you need to go and verify that if it's wrong or not. Because that's how they work.
For sure, I completely agree with you, because we use that daily, and it's true that you need to retry until you get what you want to get. But it's true that if you imagine 10 years, we can be in a different position, in a different place. And even, I have no idea, but okay, imagine, could be that this chain that we're talking about, where could be Kubernetes in another 10 years? maybe the case is that Kubernetes, what is going to be in the next 10 years, is in something controlled by any artificial intelligence that is doing everything for you, and you don't control anything. So, and you only tell, I want to deploy that here, and that's all. Reduce the cost. These kind of things. Make a security audit. Done. It could be that.
But this is the problem we discussed it on other episodes a couple of times, because in terms of Kubernetes, the next step, the next evolution for Kubernetes or infrastructure is that you don't have to manage 50 YAMLs. You have something like App Runner or Cloud Run. So you simplify a lot. And you do it not by just giving more GPUs, you just come up with a better processes, algorithms, explanations how it works. And currently, if you just say, okay, if the companies will keep like, let's buy all the GPUs from NVIDIA possible and give twice as much data, but everything else is exactly the same, okay, maybe you will get GPT-5 that hallucinates 20% less. But still, you have the same conceptual thing. So it's still an LLM. It still works in the same way. Even if it's more often correct, you can still never trust it, because the same system. There is no new scientific explanation of how it works and no new implementation. And that's currently the issue is with the current arm race of GPUs. Because there's this new beginning of this week, there was this new Chinese model that beats GPT-4 on all benchmarks. Again, okay, it beats, if it's 5% better than GPT-4, it's still less than 100% correct at all times. So in the end, you can build a better model, but the fundamentals will stay the same.
Completely. But wait 5 years, wait 10 years. I'm not telling 12 months. I'm telling 10 years. In 10 years, imagine. Can you imagine in 2014, when everything was without Kubernetes? Imagine 2010, without Docker, without Jenkins, without... can you imagine how it's going to be the world, how it is today, everything in the cloud? For sure that everything changed.
For sure. At the moment was that Docker, Kubernetes, and other things appeared. Now we can only say if the current path of something like LLM will reach like kind of a new breakthrough, and currently there is no explanation why it would. Of course, if tomorrow there will be a new type of AI model, which is not LLM, but I don't know, something completely new, yes, it's a different story. But if you see the trajectory of LLM, it's clear that first year it was like euphoria, like how amazing it is. And now we're like, okay, we can use it for this. Yes, you can use it for chatbot, for support agents, for translations, etc. But it's really this thing that will replace everything and make everything way better.
For it to be able to replace everything, it needs to be, the AI, it needs to be more powerful. It needs to consume more power. It needs more energy to be clever, to be more clever. And this is something that Goldman Sachs explores in their recent report. That said, Gen AI, too much spend, too little benefits, and they're exploring how many power it consumes and how much it costs, and that's in order to scale up, it will require even more power. And I wanted to discuss this research too. Unfortunately, I don't think we have much time to discuss this, and it's somehow repeats the things that I've been talking on my live session last Sunday. If you are interested, go and listen this, and I will post the link to this report in the description. And I think that's enough AI for today, and I think that we did a great job exploring the past of Kubernetes, the future, and how it reshaped what we already have and what we might have in the future. Anyway, guys, thank you for coming, and for those who listens to us, thank you for joining. It was a real pleasure, and as usual, don't forget to subscribe, don't forget to like, especially if you listened this far. And we will see you in next 2 weeks. Bye bye.
Thanks everyone.
See you.
Do you think your project infrastructure is well set and maintained? We know for sure there is always room for improvement. If you are uncertain where to begin, let's first do an audit of what you already have. We will review your setup from every angle: performance, cost, security, high availability, and automation, and provide you with a detailed roadmap of which direction your infrastructure should go, generate concrete tasks for you to implement, or even take on your infra entirely, if you let us, of course.